Welcome to ReneEnergy.com on YouTube, the hub for all things renewable energy and sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge developments like green hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring projects for a sustainable tomorrow. We bring you the latest in renewable energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive content. Can the unpredictable elements of nature that power renewable energy sources be predicted? This might seem like a paradox, yet it's at the core of one of the most exciting advancements in renewable energy today. Time series forecasting, a statistical method used for analyzing sequential data, is revolutionizing the way renewable energy is harnessed. In renewable energy, time series forecasting is transformative. It provides a glimpse into the future, anticipating the availability of natural resources that are inherently variable. By studying patterns in historical data, this method helps predict the intensity of sunlight for solar panels, wind speeds for turbines, and water flows for hydroelectric plants. This predictive power is essential for optimizing the efficiency of renewable energy sources and integrating them reliably into power grids. The more accurately these natural energy flows are predicted, the better the planning, storage, and distribution of green energy can be. This not only enhances the performance of renewable energy systems but is also crucial in reducing reliance on fossil fuels and addressing climate change. As the discussion unfolds, the focus will be on how time series forecasting is turning the unpredictability of nature into a predictable, reliable source of clean energy. The challenge of renewable energy sources. The inherent unpredictability of renewable energy sources like solar, wind, and hydropower poses significant challenges in the quest for sustainable energy solutions. These natural sources of energy are dynamic and vary greatly due to numerous environmental factors. Solar power, for instance, is highly dependent on weather conditions. Cloud cover, seasonal changes, and even the time of day can drastically impact the amount of solar energy available. Similarly, wind energy is subject to the whims of weather patterns, varying in strength and consistency based on geographic location and meteorological conditions. Hydropower, while generally more predictable, still faces variability due to fluctuating water levels caused by seasonal rainfall and snowmelt patterns. This variability introduces complexity in integrating renewable energy sources into the power grid. Unlike traditional fossil fuel-based power sources, which can be controlled to produce a steady output, renewable energy sources can surge and dip unpredictably. This can lead to challenges in maintaining a stable supply of energy to meet the constant demand. Accurate forecasting becomes crucial in this context for several reasons. Energy efficiency. By accurately predicting the availability of renewable resources, energy producers can optimize their operations, reducing waste and increasing the efficiency of power generation. For example, knowing when the sun will shine or the wind will blow allows for maximizing the use of solar panels and wind turbines. Grid stability. Power grids require a delicate balance between supply and demand. Sudden changes in energy production from renewable sources can destabilize this balance, leading to power outages or the need for emergency backup systems. Forecasting helps grid operators anticipate these changes and make adjustments to maintain stability, such as by rerouting power or adjusting the output from other power plants. Economic planning. Accurate forecasts enable better decision-making for energy purchasing and infrastructure investments. Utilities can plan more effectively for energy storage solutions and decide when to buy or sell energy on the market. Integration of renewable energy. As the world moves towards more sustainable energy solutions, the ability to predictably integrate renewable sources into the energy mix becomes increasingly important. Effective forecasting is key to achieving a higher penetration of renewable energy in the power grid while ensuring reliability and cost-effectiveness. In summary, the unpredictable nature of renewable energy sources presents a significant challenge. However, through the advancement of time series forecasting techniques, it's possible to mitigate these challenges, paving the way for a more sustainable and reliable energy future. What is time series forecasting? Time series forecasting is a method that might sound complex at first, but it's a concept we encounter in everyday life, especially in something as familiar as weather forecasting. At its core, time series forecasting is about analyzing data points that are collected over time to predict future values. Let's break this down. A time series is simply a sequence of data points recorded at regular time intervals. This could be anything that is measured sequentially over time, like daily temperatures, stock market prices, or, in the case of renewable energy, the hourly output of a solar panel. Forecasting, then, is about using this historical data to make informed predictions about the future. It's like looking at patterns from the past to anticipate what might happen next. For instance, meteorologists use time series data of weather conditions to predict tomorrow's weather. They analyze past temperature patterns, humidity levels, and wind speeds to forecast if it will rain, snow, or stay sunny. In the context of renewable energy, time series forecasting plays a crucial role. Consider a solar energy farm. By analyzing past data on sunlight exposure, which varies with time of day, cloud cover, and seasons, energy experts can predict how much solar power will be generated at different times. This helps in planning and ensuring there's enough energy to meet demand. Similarly, for wind energy, historical wind speed and direction data are analyzed to forecast how much power wind turbines will generate. In hydroelectric power, past data on water flow and reservoir levels can help predict future electricity generation. In essence, time series forecasting is about finding patterns in historical data and using these patterns to predict future events. This method is invaluable in managing and optimizing renewable energy sources, making them more reliable and efficient. By understanding and predicting nature's patterns, we can harness renewable energy more effectively, paving the way for a greener future. The science behind forecasting. Time series forecasting, particularly in the realm of renewable energy, hinges on the use of sophisticated statistical models and machine learning techniques. These methods may sound intricate, but they can be understood through simple analogies and concepts. Statistical models. Think of statistical models in time series forecasting like a skilled chef following a recipe. Just as a chef uses specific ingredients and steps to create a dish, statistical models use historical data, the ingredients, and mathematical equations, the recipe steps, to predict future data points. A common type of statistical model used in time series forecasting is the autoregressive model. Imagine predicting the future height of a plant by looking at how much it grew each day in the past. You're using past growth, previous data points, to estimate future growth. That's the essence of an autoregressive model. It assumes that future values in a series are related to, or regress on, its own previous values. Machine learning techniques. Machine learning in forecasting is like teaching a child to recognize patterns. You show them examples, data, and over time, they learn to identify and predict these patterns on their own. Machine learning algorithms are trained on historical data to recognize patterns and make predictions about future data points. Advanced techniques like neural networks, which are inspired by the human brain structure, can identify complex patterns in large datasets. Imagine a network of interconnected nodes, like neurons, that process information and learn from it, much like how our brain learns from experiences. Combining models for better accuracy. In practice, forecasters often use a combination of different models to improve accuracy. This approach is akin to a team of experts, each with their own specialty, working together to solve a complex problem. Each model contributes its strengths, compensating for the weaknesses of others. Applying to renewable energy. In renewable energy, these forecasting models analyze data like sunlight intensity, wind speeds, and water flows over time. They learn from this data to predict how much energy can be generated in the future. Impact on renewable energy. The impact of time series forecasting on renewable energy sources like solar power, wind energy, and hydropower is profound and transformative. It enables more efficient and effective harnessing of these natural resources. Solar power. Solar power generation is directly affected by the amount of sunlight that solar panels receive. However, factors like cloud cover, seasonal variations, and the time of day make sunlight availability highly variable. Time series forecasting helps predict these sunlight patterns. By analyzing historical weather data and current meteorological inputs, forecasters can predict periods of high or low sunlight. This information is crucial for optimizing the output of solar panels. For example, with accurate sunlight forecasts, solar farms can adjust the angle of panels for maximum exposure, plan energy storage during peak sunlight hours, and even anticipate lower production periods. This not only maximizes energy production but also ensures a more stable and reliable energy supply to the grid. Wind energy. Wind energy relies on the strength and consistency of wind patterns. Like solar power, wind is also subject to environmental fluctuations. Forecasting in wind energy involves predicting wind speeds and directions. Using historical wind data and real-time weather information, models can estimate how much energy wind turbines will produce. Accurate wind forecasts allow wind farms to optimize turbine operations, such as adjusting the pitch of the blades for maximum efficiency. It also helps in determining the best locations for new turbines and preparing for periods of low wind, ensuring a consistent energy supply. Hydropower. Hydroelectric power is generated by the flow of water, which can vary with seasonal rain and snow patterns. Time series forecasting in hydropower involves predicting water flow rates and reservoir levels. This is done by analyzing past rainfall data, snowmelt patterns, and current water levels. Accurate water flow predictions enable hydroelectric plants to plan their operations more effectively. They can adjust the flow of water through turbines to optimize electricity generation and manage reservoir levels to prepare for dry or wet seasons. This not only maximizes energy production but also helps in maintaining ecological balance and managing water resources efficiently. Real-world applications. Time series forecasting has led to numerous real-world successes in renewable energy, showcasing significant improvements in efficiency and productivity. These case studies often involve collaborations between technology companies specializing in data analysis and renewable energy firms. Solar energy optimization. Case study: California solar farms. In California, several solar farms have implemented advanced forecasting systems. These systems use historical weather data and real-time satellite imagery to predict cloud movements and sunlight availability accurately. The result has been a marked improvement in energy output forecasting, allowing grid operators to better integrate solar power with other energy sources, reducing reliance on backup fossil fuel generators. This collaboration between tech companies providing forecasting algorithms and solar farms demonstrates the power of data-driven decision-making in renewable energy. Wind farm efficiency. Case study: offshore wind farms in the North Sea. Offshore wind farms in the North Sea have utilized sophisticated wind prediction models, integrating oceanographic data and atmospheric conditions. These forecasts have enabled wind farms to optimize turbine operations and maintenance schedules, leading to a significant increase in energy production and cost savings. The partnership between meteorological data companies and wind energy developers here highlights the importance of precise environmental data in enhancing renewable energy sources. Hydropower management. Case study: hydropower in the Pacific Northwest. Hydropower plants in the Pacific Northwest have integrated time series forecasting for water flow and reservoir levels, using data from snowpack measurements and rainfall predictions. This forecasting has improved the balancing of electricity generation with water resource management, ensuring efficient energy production while maintaining water levels for ecological and recreational purposes. The collaboration between environmental agencies and hydropower plants in this case study is a prime example of how data analytics can optimize renewable energy while respecting ecological needs. Cross-sector collaboration. Case study: European Green Energy Initiative. A pan-European initiative brought together data scientists, renewable energy companies, and government agencies to create a unified forecasting model for solar, wind, and hydropower. The project led to enhanced grid stability and more efficient energy distribution across multiple countries, showcasing the potential of collaborative efforts in advancing renewable energy. The future of forecasting in renewable energy. Advancements in AI and machine learning are poised to revolutionize time series forecasting in renewable energy. These technologies are becoming increasingly sophisticated, enabling more accurate and nuanced predictions. Advanced AI models. Future AI models are expected to process vast and more complex datasets, including satellite imagery, sensor data from renewable energy installations, and even social media trends that can indicate energy usage patterns. These models could predict not just weather patterns but also energy demand fluctuations, leading to highly efficient energy distribution systems. Machine learning and IoT. The integration of machine learning with the Internet of Things, IoT, will allow real-time data collection and analysis. Sensors on solar panels, wind turbines, and hydroelectric dams will provide instant data, helping to adjust forecasts in real time, vastly improving response times to environmental changes. Impact on energy sustainability and climate change mitigation. Enhanced forecasting will enable a more substantial shift towards renewable energy sources, reducing global reliance on fossil fuels. This shift will significantly impact climate change mitigation efforts, as a more efficient and reliable renewable energy sector means lower carbon emissions. Additionally, better forecasting will facilitate the integration of renewable energy into national grids, supporting the goal of sustainable and clean energy for all. Conclusion. Time series forecasting is an indispensable tool in the renewable energy sector. Its importance in optimizing the efficiency and reliability of renewable energy sources cannot be overstated. As we look towards a future where AI and machine learning play an even more prominent role, the potential for groundbreaking improvements in renewable energy systems is immense. Thought-provoking question for the audience. How do you think improved forecasting methods will change the future of renewable energy? Imagine a world where renewable energy is as reliable as traditional sources, thanks to advanced forecasting. How do you see this impacting our everyday lives and the global efforts towards climate change mitigation? Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.